So in order for us to be able to define the inverse of a function, we need to first clarify and classify what one-to-one functions are. So here's our definition. We want to let y equals f of x be any function defined on the set of real numbers, and we say that that function f is one-to-one if the following holds true. So we say that a function is a one-to-one function if for all x sub 1 and x sub 2 in the domain of this function f, if x sub 1 does not equal x sub 2, then f of x sub 1 cannot be equal to f of x sub 2. Now, an alternative and equivalent way to think about this is the statement that if f of x sub 1 is equal to f of x sub 2, then x sub 1 must be equal to x sub 2. And again, this is for all elements x sub 1 and x sub 2 in that function's domain. Now, this is pretty formal, or this is a formal definition here. So what exactly is this telling us? So perhaps an easier way to think about this definition is that each y value in the range of the function is going to correspond to one and only one x value in that function's domain. So to help us better appreciate this definition, let's explore the following example. So looking at this list of ordered pairs and trying to determine if this function or this set of ordered pairs represents a one-to-one function, a nice place to start is by checking the y values. So notice here with our first point and last point, these two ordered pairs have the same y but different x's. So let's relate this observation here to our definition. So we can observe here that those y values are the same. In other words, that f of 1 is equal to f of 3 is equal to 2, but x equals 1 and x equals 3 are not the same. So this violates the definition and tells us that this set of ordered pairs does not represent a one-to-one function. So in addition to this formal definition and checking ordered pairs, we also have a great graphical test that we can use to verify if a function is one-to-one or not. So let's go ahead and take a look.